today we're going to graph inequalities in two variables, which sounds complicated, but it's pretty much just graphing in slope-intercept with one extra step. Okay, so let's start off with some conceptual stuff. So first, is 4, 3 a solution to 2x minus y is less than 4? So what we'll want to do is plug in our points and then see if it's true, right? So the answer to this should be yes or no. So we have 2, 4 minus 3, right? We plugged in 4 and 3, less than 4. This is saying 8 less than 3, minus 3 is less than 4. Is 5 less than 4? No, 5 is not less than 4. You wouldn't need this like in your homework or anything, but it's just for you to understand. Right? Okay, next one is negative 2, 0 a solution to y is less than 2x plus 4. So we have our y is 0, less than 2, negative 2 plus 4. 0 is less than negative 4 plus 4. 0 is less than 0. 0 is not less than 0, so no. If it had been less than or equal to, then yes, right? Because then it would be yes, 0 is equal to 0. But these two are no. Okay, so when we're graphing linear inequalities, we have 3 steps. The first step is to put into slope-intercept form and graph, and plot points. Right? So the difference between graphing is like when you draw the line, plotting points is just like putting the points. Okay, 2, we have a dashed line for less than or greater than, and a solid line for less than or equal to or greater than or equal to. And then finally we shade depending on test point or shortcut. So this is our shortcut. It's down here, so we'll talk about that later, right? This is where the shortcut is. Okay, so let's do an example. So we have y is less than or equal to negative x minus 3. So we just treat it like a normal slope-intercept. This is already in slope-intercept, so we don't really have to put it in the form. We just have to plot the points. So we're going to start with negative 3. We see that we have a negative slope, so our line needs to look like this. And it's negative 1, so we're going to plot our points. And since there's a less than or equal to, since there's that line there, we can just make a straight line. Okay, so I want to, so now we're on 3. We want to shade depending on test point or shortcut. So we're going to do test point first. So the easiest test point, let's put this over here. Easiest is 0, 0. Okay, so if the test point works, the whole section works. Okay, so what does that mean, right? So I'm going to test 0, 0, right? And I'm going to put it in sort of like we did at the very top. So I'm going to do 0 is less than or equal to negative 0 minus 3. So that's saying 0 is less than or equal to 0 minus 3. 0 is less than or equal to negative 3. 0 is not less than or equal to negative 3, so this section doesn't work, right? If this test point worked, the whole section would be shaded. But since it doesn't work, we have to shade the other side. So now we know that anything in this section or on the line, because it's solid, will work. So let's take an example. Let's do negative 4, 0. So we have negative 4, 0. So we have 0 is less than or equal to negative 4 minus 3. 0 is less than or equal to 4 minus 3. 0 is less than or equal to 1. That's true. So see, everything in the shaded section works. Everything in the other section doesn't work. So that's how we do a test point. Okay, let's look at a few more examples. So the first step here is to turn it into slope-intercept form. So we're going to move the y over. Negative 20 minus x. And then we're going to divide by 4. So we have y is less than, we're going to do the x term first. Negative 1/4 x minus 5. So this is our slope-intercept form, and then we got to graph it. Minus 5. We have a slope of negative, so the line should look like that. And then there's no line there, so we're going to dot it. So now we're in step 2. All right, so we have our line. We did step 1 and step 2, and now we need to do step 3. We're going to do a test point. So again, the easiest point is always 0, 0. And we could put the test point in the original equation or the slope-intercept form, whatever is easiest for you. So I'm going to do it in the slope-intercept form. And sometimes you could do this in your head. You don't even have to write it down, but whatever works for you. 0 is greater than negative 5. That is true. So 0, 0 is in the section, right? If the test point works, the whole section works. So anything in this section will work. We just have to make sure we're not on the line because it's dotted, right? Whereas here we could be on the line. So here we could have put in 0, negative 3 and it would have worked, but here we can't put in 0, negative 5 or else it won't work. All right, one more example. Actually, let's talk about the shortcut. Okay, so the shortcut, if y is greater than mx plus b, or y is greater than or equal to mx plus b, then shade above the line. And if it's less than, then shade below. Okay, so let's try it with the shortcut. So this is already in slope-intercept form, and now we just need to plot the points. So we have our y-intercept of 1. We have another negative line. All right, so all of our examples today are negative slopes. A lot of you are still getting messed up with your slope. So make sure you know what positive slope and negative slope, like what the difference are. Okay, so we're gonna go down 6 over 5. And we have a dotted line. And we're gonna do the shortcut. So it says less than, so we're gonna go below the line. Right? So right, so let's just prove that it works. Let's do the test point. Let's do 0, 0. So 0, 0 should work, should be true for the whole section to be shaded. So we have 0 is less than 0 plus 1, 0 is less than 1. That's true. So, right, this test point worked, and then we can look at back here and show that the shortcut works, right? So this was less than, and it was less than the line. This one was greater than, and it was greater than the line. So whichever one you prefer, test point or shortcut, doesn't matter. All right, let's take a look at a word problem. Miss Letts and Mr. Aldana are raising funds to go to a math conference in Graceland. Miss Letts makes about $15 for every hour she fundraises, and Mr. Aldana makes about $5 for every hour he fundraises. They figure they need to raise $100 to go. Okay, so we need to write an inequality. So if we think about it, we have two people working, but the hours could be different, right? So we have two different variables. Letts and Aldana can work different number of hours. So for our inequality, we're going to have 15x, so that's $15 an hour for every hour that Miss Lutz works, plus 5y needs to be greater than or equal to 100, right? So x is hours Miss Lutz fundraises, and y is hours Mr. Aldana fundraises, right? So this is me defining the variable. Okay, so we need to graph it. So in order to graph it, we need to turn it into slope-intercept form. So we're going to minus the 15x from both sides. We're left with 5y is greater than or equal to negative 15x plus 100. Then we're going to divide by 5. So we have y is greater than or equal to negative 3x plus 20. So we're going to start up here at 20. Remember, we have a negative slope, so it's going down like that. So every one we go over, we go down 3. It's a solid line because of the equal, so we can just draw our solid line. And we don't need to have arrows at the end because this is a real world problem, right? We can't have anything, we can't have negative hours fundraised. All right, so we wrote the inequality, we almost graphed it, we just need to do the shading. So, right, this is greater than, so it's going to be above, which makes sense, right? Because if we both fundraise a ton of hours, of course we're going to make $100. All right, what are 3 possible combinations that would allow them to go to Graceland? So we could look at any point on here and it would work, right? So we could pick a point on the line, we could pick like 0, 20. We could pick a point like on the line here. Right, we can make it equal, or they each work 5, 5. We could pick a point here, right? 10, 0. We could pick a point here, right? 8, 17. So this is pretty much saying Miss Lutz works 0 hours, Aldana works 20 hours, right? And that means together they'd have 100, and that would be enough for them to go. Not really fair, right? Here, Miss Lutz would work 10 hours, Aldana would work 0 hours, and they'd make a lot, right? They'd have 150. So there's infinite possibilities, right? So this problem just wanted you to list 3. They could be on the line because it's dotted, or they could be in the shaded part, and that is enough for them to go, right? They would have at least $100, right? Anything above the line, they'd have more than $100. All right. One final one, so I want you to pause the video and graph this and then check back and see if you got it. So pause the video. And if you're back, we are going to slope intercept. So I'm going to do it over here. 5x plus 4y is less than or equal to negative 12 minus 5x from both sides. We have 4y is less than or equal to negative 5x minus 12 divided by 4. Y is less than or equal to negative 5 over 4x minus 3. We're going to graph it. We have a negative slope again. It's a solid line. And it's less than. So that's as quick as it should be. 2 things to remember that we didn't encounter is dividing by a negative number. So just remember when dividing, multiplying by a negative number, you flip the sign. So just don't forget that. We learned that in like 7.3. But yeah, all you have to do is graph and shade. And you can use either the test point or the shortcut.